Okay. Sorry about that, guys. I was muted for a little bit, but the first thing I had up was the challenge Find the Flag on our website. And there's a couple ways you could solve this. One is to go to our code base and just find the flag in there because it is open. The other way is, okay, you can also just Google uh, filter by site, right? And then you can also just search for the word flag. Um, So this will only show results from our website. So and it will only show results that have the word flag in them. So you can see that this is here. You can also do a bunch of other cool stuff. You can filter by like type. So if you could do like PDF or different kinds of file types that Google might crawl. You can do like ands and ors for certain combinations of keywords. And in general, this is pretty useful if you're looking for like publicly exposed admin dashboards, or someone accidentally uploads like PDFs, internal documents, and doesn't actually secure them. It's also like a really easy thing to just try out. I think when I was in like eighth grade, I found a bunch of documents on my school's stuff, like internal like committee meeting notes and stuff, and like floor plans and stuff that were accessible because they didn't actually secure their documents, and it was pretty easily accessible. Okay, let's see. Okay. I thought that was pretty interesting, but not like worth a full meeting. So that's why I just put it here at the beginning. But mainly our meeting is going to be about Pyjails. Yeah.
Just a question. Is there anything about the website that might point people towards back to the code base of open source?
I don't think we have a link to our GitHub on the page. No. Yeah. 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 So .github.io domains are GitHub pages. So those can be, I think, public or private GitHub repos, but often people will make them public. So yeah, that is a pretty good hint that it was open source. Okay. And if you guys haven't joined our Discord or our Instagram, you guys should do that. Okay. If you guys haven't met me yet, I'm Nash. I'm the CTF captain. That's Sean. He's also our CTF captain. Um, okay. We are working on a couple of projects right now. First, we're doing the LLM CTF project, which is something that we're continuing from last year. We're looking for new people to join, and we've created a new application form. There's going to be a QR code up there, and also there's the form link, which is going to be in the slides, and I'll post it in announcements after. If you guys are interested in joining and helping out, I think it's really cool. We're making an agent that uses some state-of-the-art models to automatically solve CTF challenges, which will hopefully help us a lot in the upcoming competitions. We're also going to be hosting a CTF of our own, Rec CTF. We're looking for people to write challenges. If you have some experience doing CTFs or writing challenges for CTFs, you can reach out to like me or Socket just on Discord, and then we can tell you what you need to do. Okay. Based on the fact that you guys are here, I think you know where the meetings are. But oh, okay. This is the old location, but we're going to be in this room every Tuesday and Box B5 every Thursday. We're going to alternate between web and miscellaneous style stuff and RevPwn stuff. And also, we have a Google Calendar if that's a little bit more convenient than checking for the announcement every time. Okay. So the date for Sturdenlen finally came out. It's going to be 24 hours from Saturday, February 28th to the Sunday, March 1st, 1 p.m. to 1 p.m. So a pretty short one. And then CTF is going to be March 7th to March 8th, also about 24 hours. So another short one. Okay. Something you should keep in mind for the upcoming CTFs, you probably want to submit a write-up if you guys end up solving a challenge. I think it's a great opportunity to go over what you did at the CTF and formalize it right down, and then you can show it to others to show that you really know what you're talking about. And you can be on our website. So this is the form. I'll have it up the meeting after the CTF. Okay. So I put together a few exercises that I'm gonna walk through, going from some simple Pyjails to a little bit more advanced ways to break out. So this is some public repo that you guys should be able to just clone. I'll give you guys a minute to do that. So this is going to be building a little bit off of last week. I think Sean introduced you guys to a little bit of basic Python. So we're going to be going a little bit more into the intricacies of like Python syntax and all the features that it has available. I think Pyjails are pretty fun because they're like pretty creative. You need to work around all the restrictions placed on the execution environment. Sometimes they'll have certain language features that you can't use, certain characters, certain strings that they'll have blocked, and stuff like that. And yeah, okay. Okay. Was everyone able to clone the repo? Um, the answers like are all in there if you guys want to continue this after the meeting. I don't think we'll probably get to all of them. Um, but I would refrain from looking at the answers until you've tried it on your own for at least a little bit. Okay. So they're organized into just a folder for each example. So let's go into the first one now, and we can see what example one is about. Okay. So this one. So basically, we're reading user input, right? And then we're just running. Um, yeah, and then we're just running eval on it, right? So we're just taking user input and we're running it. So there are a lot of situations where you might have a service on the internet that might accept some sort of code from a user, right? So there are cloud, editors and such like Replit and stuff like that, um, where you might be executing something on a remote server. There's also stuff like maybe like spreadsheets and stuff. Usually that executes on your own computer, but maybe you have some sort of spreadsheet software where you have a formula that you define and you send it out and it computes it for you. There are automation platforms where sometimes you'll write custom code if you want to have a complex filtering logic. Say you want to do something, some action when you get some sort of email, and then you want to interact with some other API, right? So there are automation platforms that allow you to bring in code like that. So there's a lot of services online that require that you be able to input custom logic in. So this is something that you might see online. So there's a flag file in here, right? How would you get out the flag, given that you can just give it any code and it will run it, right? So you can test it out on your own computer just by doing example one slash, okay? And then it'll just give you a prompt and you could type in a command. So we can say, so this is an eval, right? Okay. So we can do, give me a second. Okay. So Is anyone able to get out the flag? Yeah. What did you run? What did you say? Okay. Dot read text like this. What? Oh, okay. Yeah. So you can see how the stuff in the environment, right? So flag path is uh, it's something that we imported from pathlib. So it's the path to the file, which already exists in our environment. And then you can just call read text on it in order to do that. So usually when you have an environment where you're executing code, it'll strip out all of the variables from the other context, right? But here you can access all the variables that were defined outside of the eval. Another thing that you could also do, right, even if you didn't have access to those variables, is you could do something like open to open a file, and if you knew where it was, you could do something like dot slash dot txt, right? That gives you the file object, and you could do dot read, and you can get out the flag. What if you didn't know the exact path to the flag? Does anyone have an idea of what you might want to do? Yeah. Yeah. So dir does give you all of the variables in here. But I was talking about if you don't know the path to the flag like on the file system, right? How would you try to find that? Yeah. 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 But so you don't actually have OS in this context, right? Actually, oh wait, it's already imported, right? Okay, so it is actually imported, right? So you can do os.system, and what that's going to do is that's just going to run shellcode. So you could do ls, right? That's a command that you could run, and you can see everything that's in here. And then you could do cat flag.txt, right? And that would come out as well. Um, so yeah. So you're rarely going to have a case where it's just going to accept any code and just run it. If you do, you got pretty lucky. Um, so a lot of times, what they'll try to do is we'll go to example 2 next. They're going to restrict what you can actually access. So if you're trying to read a file out, right, you have to use, os.system or read or some other method. So sometimes people will just have filtering logic where they'll check for those keywords to see if you're trying to attack the system. So okay. So you can see in here, we have certain keywords that are blocked, right? So you can't use OS, system, open, all the things that we use in order to access the file. Um, the the first thing that we tried, which was flag class.readText, was actually not something I thought of because I forgot that was in the environment. So that's not actually blocked right now. So that would actually still work. But see if you can find another way in order to access the flag. So yeah, that's still in the path. The flag path's still in there. But there are other ways that you could access this. Has anyone found a way to access the flag without using any of these block keywords? Yeah, someone find it. Yeah, I'll wait one more minute and then I'll show you how I would go about it. Okay. If no one's found anything yet, I'll give you guys a little bit of hint. So when you guys run something like open, right? That's blocked. But if you were to actually, let's do regular Python. Okay. So if you were to do something like open, right? So that's a built-in function, it says here, right? So that's accessible even without you declaring the name of the variable and then assigning like a function to that. So that exists already in the shell when you start it up. So all of those things are called built-ins. So Python actually has a list of built-ins, and it's called double underscore built-ins, built-in. Okay, there. So yeah. Okay. So there's a lot of stuff in Python, special properties, lists, modules, stuff like that. Everything has double underscores to signify that it's an internal Python construct. So as Socket said earlier, we can run the dir function, I think which stands short for directory, which shows like everything that exists inside of this module, right? So you have all of this stuff, and you should recognize all of this as the normal built-in functions that you should be able to access, right? Without declaring them or anything, they're built in. So what we can do is we can do access that here, right? And then we can do where did my cursor go? Here. Okay. So from there, we can access open, but we can't just do .open because that would require typing out the word open, right? Um, and we can't exactly use string indexing. I think in like JavaScript or something, you might be able to access like a method just by doing a string index. But in Python, indexing and accessing a method are kind of different things. So this wouldn't, okay, this will get blocked by a filter anyway. But yeah, it's not subscriptable. So subscript is different than accessing method. So in Python, when you want to access a method, you can either use the dot operator or there's a built-in function called getAttr. So this gets the attribute let's see, let's do a different one just so it doesn't get blocked. All right, this would get the built-in function max out of there. That would be just equivalent if we did built-ins dot max or just max by itself. So now that we can use an actual string in order to access open, right? We can write code that generates the string open. So what are some ways you might write code to generate the string open without typing out the word open by itself? Yeah. So you can split it up and add them together. And now we have the open function. Are there any other ways that you might want to do it instead of splitting it up? Yeah. Okay, yeah. So you could shift all the layers by one and write some code to unshift them back. So there's a lot of different ways that you can do this. If you think about different ways that code is obfuscated, right? If you ever like looked at malware or just some compiled code that was like obfuscated for some sort of security by obscurity, right? You can see a lot of different techniques that people use. Something that people might use is, for example, they might use escape characters. So you can do \x and you can put the hex code of the character in. So I think what's it? 6 for lowercase letters, and then I think 0, 1, 2, 3, 5. Right? Okay. So E is the 5th letter, so you would put 5 there, and then you could just do that for the rest of them. I don't know which position in the alphabet O, P, and N are, but really you only need one of them. And then it doesn't match the filter, right? Some other stuff you could do is you can use the CHR function, which just turns like an integer into a character. And there's like so many other ways that you could do this. So yeah, there's plenty of ways to do that. Okay, and then the other thing I will say, where'd my question? Okay, I did say how you can't subscript open, right? Like this. But you can turn it into a dictionary that you can subscript if you use the built-in var function. That will take everything that exists in built-ins, all of the methods and properties, and put them into a dictionary. And dictionaries are subscriptable, so you'd be able to do this if it wasn't blocked. 1 second. It has an S, vars. Okay, so now we have the function open, right? So that's one example. I think that's everything I want to go over for this one. Okay, and then let's go to the next next one. So I have another one in the same folder where we're just blocking a little bit more. Let's see. What is it autocomplete like this? Okay. Okay. So in this one, let me pull that up. So we also can't use getAttr and vars. So this is in this situation, we can still get all the properties using the double underscore methods. So let me okay. So if I go into built-ins and I can tab and I can see everything that exists underneath it, right? So built-ins has all of these built-in things, right? So these are all errors that are built into Python, and you can just access them without importing anything or defining anything. But it also has certain special properties. I believe that you should just be able to do this. Does that work? Yeah, okay. So I don't know why that didn't autocomplete when I pressed tab, but if you do double underscore dict, what that's going to do is it's going to do the same thing that vars did, right? It's going to turn it into a dictionary of properties that you can access. So I can go here and I can do built-ins. And then I want to access the open. This time I'll go all the way and I'll actually get the flag. But once you have open, you know how to do it from before. Okay, so we have the open function, and then we can just call that on flag.txt. And then now we have the flag, and we can do .read, and we can get it out. And if they were to block, for example, flag.txt, you'd be able to construct that string the same way that we constructed the open string, right? we showed a few ways you can add different strings together. You could write some code to permute a string. You could encode it, with escape characters. So there's a lot of different ways. If they block the .read method, you'd be able to do it the same way that we did the open method of built-ins. Okay. Let's see. Let's go to the next one. Okay. So if you scroll up a little bit, you can see last time what we did was we used quotes a lot, right, to define strings. But in this one, we can't use any quotes. I'm going to pull up the source code. So does anyone have any ideas how you might construct a string if you couldn't use quotes in Python? Yeah? Jason. Um, elaborate a little bit more.
Use like corresponding ASCII characters and turn into characters.
Do you know of like the specific function or syntax you would use to do that?
CHR.
Yeah, so CHR is a function that takes in a number. Let me just put in a random one. Okay, that is, I don't have an A. Okay, so that outputs like a letter in the alphabet, right? So that's actually a little bit easier for me to do it if I do it in hex. So if I do something like 64, right, that outputs letter D, right? So you can construct it just from numbers and from functions. Sometimes though, there'll be a character limit, right? So in the Pyjail, they won't let you put in like a crazy long string. So if you had, what is that? 1, 2, 3, 4, 5, 6, 7, 8 characters for every one character of the string. Plus you have to have a plus sign. So that's really 9 characters for every one character string. That is going to take up a lot of space for you to construct any meaningful string, right? Does anyone know of a shorter way that you could do this? Yeah.
Maybe like a list comprehension with
Yeah, so that's exactly where I was going, right? So what if you had a bunch of these together and you didn't have to call the CHR function, you didn't have to write out each time, but you wrote it out once and then you did it for every single value. So if you had a list of like 111, 112, 113, and so on, right? What you could do is you could iterate over that with like a list comprehension and then get it. But there's a way to do it without using a list comprehension. So Python actually, you can give it, I'm just going to paste this in because I don't want to type this out, right? So you can give it a whole number and you can say it has this many bytes and you want to convert each of them into a string. Well, it's going to be a binary string, but same thing, right? So I can get the value open out. You can see each of these groups of 2, 6E is open, 6.5 is E, as we went over before, right? So each one of these is getting converted into a byte. So this is a little bit better. We have a fixed cost of 2 bytes, right? And we also have 2 characters for every 1 character that we're getting out in the string. So that's pretty decent. There might be a better way to do this, though. Does anyone have any ideas? I know of one other better way. You guys might be able to come up with something better if you think about it. But Python is very dynamic and introspectable language. So you can write code that very easily modifies parts of Python itself, right? So one thing that you can do is in the code itself, right? You can find, if you're passed a function, right? You can find the name that that function was defined under. If you're passed like a variable, you can get as a string the name that that variable is defined under. So let me just go down here to an actual Python. So if I type my var variable, right, and I set that equal to 1, what I can do is I can inspect my variable, and Python saves a bunch of information about it. But something that we're interested in does tab complete work for this? Okay, it actually got cut off, so you can't see it. But if I type in let's see. Uh, if I do, okay, 1 second. Let me get out an example. Okay. Okay. So, okay, yeah. Okay. So this is what I was gonna do. So if you have the dir function, right, it'll list out every single variable that you have defined. So, since I defined function, the variable my var, right, you can see how that shows up because every variable that you have defined in your context that you can access shows up with dir. So what you can do is you can define a variable, right? So you can define a variable, maybe called open or something like that. Or if you have flag.txt you want to get, you can't type in the word flag, you can define you can't use quotes, right? But you want to get the string, you can define a variable with that, and then when you run dir, then it'll be inside the list that you get out. And this is something cool that I saw from someone else during LACTF on Discord. So I just thought that you guys might be interested in seeing that. So what they did was they used here. So they made a lambda function and they added one parameter to it with the name of the string that they want to get, and then they ran dir inside that. And since there's only one variable available inside that lambda function, local variable available, then it only prints that out. And then so if you add a 0 to get the first element, then you just get out that string back. So I thought that was pretty cool. Okay. But yeah, there's a lot of ways to do that. That was just a few that I thought were pretty interesting. Okay, I'm gonna move on to the next example folder, and then I think from there I'll leave you guys to work through a couple of the rest of the problems in here by yourself. There'll be examples, and there's also a couple of challenges that we have on our internal CTF testing platform that you guys can work through on your own, and then I'll walk around. So yeah, let me go through this last one. Okay, so example 3. Okay, so here, when we're constructing the eval environment, right, we're removing all the built-ins. So if I come in here and I try to do something like open, right, it's not even defined there. We don't have to worry about blocking it because nothing even exists here. So if I run dir here, right, dir is not even defined, so I can't even list it out. But if it was able to list out the local variables and stuff that we have defined, you can see that we couldn't really access anything. Let's see about built-ins. Right? So all the built-in stuff, it's an empty dictionary. So there's nothing really in there for us to access. Does anyone have any ideas about what we might be able to do here? What can we access? Anyone have any ideas? If you have it up on your computer, you can just try typing stuff in and seeing what works. So you might notice that if we like type in a number, for example, that works. We get the number back, right? And as I said, in Python, you can. So actually, my keystroke's going through. Yeah. Okay. Oh, 2. Okay. So we have a number, right? Let me do this down here so I can get the autocomplete. We can see what we have available on this number. They need to define it into a variable. So we have all the methods on this, right? So let's go up here, and I don't know, real, just because that exists. Okay, so we can get that. Let's get like maybe a function from bytes. So now we have access to a method, although this is not exactly super helpful. We do have access to one of the methods of the integer. So if no one has an ideas yet, I'll share how you're supposed to solve this, right? So since you have access to through the Python syntax to creating certain objects, what you can do is use the introspective nature of Python to see properties about those objects. So Python is like object oriented, right? So you can see superclasses and subclasses, and so if you have an instance of the number, right, you can check what type it is and see that's a number, right? So we don't have the type function because we don't have built in, so we can't exactly do that. But if we have a number, right, what we can do is we can do dot underscore underscore class, and that gives you the integer class, right? And then I don't know if you guys are wondering maybe what class is an integer. Well, we can find out. So that's actually just a class of type. I think that's the base class for like everything else, really. So if you just do class again, then that'll just give you type again. But now that we have so yeah, so all classes are of class type, but classes can also have superclasses and subclasses, right? Hopefully you guys know this from like, I don't know, intro to object oriented programming, probably one of the first classes you're going to take here. We can do this down here. So x dot class. What do we have available here? Super, super, I think. Oh, not type that right. Super class. How is that called? Oh, it's I think it's called base. Yeah. So in Python, it's like a base class that you're going off of. So I do base, right? It's off of object because integers are built off of objects, right? They're extended from object. So I do base here. We have object, and Python, everything is an object, right? So since everything comes from object, we'll be able to find anything from object. So if I go back down here, I can do more double underscores. I can do sub classes. Does that work? Yeah, so this is a method, so let's call this. And now we get every single subclass of object. Now, every subclass of object is just every class that exists, right? Because everything's subclass of object. If I took away this base, then I would only get subclasses of integers. So a Boolean is a subclass of integer because basically an integer that's either 0 or 1. And you can see the other types of classes that are subclass of integers. But now that we have every subclass of an object, right, we can find every class that exists. So unfortunately, most of the built-ins are actually functions, right? They're not actually classes. But they're there are methods on these classes which are basically functions themselves, right? So one of those is, can I search here? Control S search. So we're trying to access a file, right? So what kind of file classes are there? There's file finder. So let's see. So you can see up here, right? We have file loader. So that's a class that exists in Python. So if we can get out of this, okay. So if we want to get the file loader class, we can get that off of this list that it gives us of all the classes. But let's see, loader. What was it called? Loader. Okay, it's not defined here. Anyway, Okay, so yeah, file loader is not a built-in, but it is a class that exists that we can access. So now that we have a list of all the classes, does anyone know how we might filter down this list just to get the file loader? Since we're in an eval, right, we can't just assign it to a variable and then loop through it separately. We're gonna have to loop through it inline. So if any of you are familiar with Python syntax, you might know of list comprehension, right? That's how you can loop through something inline and check. So we can do for actually do this in the beginning. We can do a for a in. So that says every single class that exists, we're going to output it if it matches a certain condition. So we can say a dot underscore underscore name equals file loader. Does that work? Yeah. So now we got out a file loader. And so we can access the double underscore name because this is like a class. So like a variable wouldn't have a double underscore name because you can assign multiple variable names to a single object, right? But an object has like a name, one name. So a class has a single name, a function has a single name, a method has a single name, right? So those will be defined as properties underneath it. And then we can get the first one. And then now we have a file loader. And then now that we have a file loader, we can just, I think the second argument is the file name that it takes in, flag.txt. And then I think it does the get underscore data method. Okay, I have to put the flag path in again. Flag.txt. Okay, so this is not executing inside the actual Python jail. So let me copy this in and then show you. That is because it had a line continuation. Okay. Okay. And let me define this. So you could do this on any class. You can do it as on integer 1. You could do it under a string. If you just have parentheses, that actually counts as a tuple in Python. So that's another way to save characters if you're looking to do that instead of just putting a 1 inside the parentheses. And then you can get out the flag like that. I'm going to leave the rest of them up to you since we're getting close to the end. Let me go back to the slides right now. Okay. So, right. Those will be up publicly if you want to go through the rest of them. So on the CTF platform, I went through this last meeting. You should be able to sign up with your GT emails now. All the emails should work. I've started fixing some of the broken challenges. ML/logistics from RecCTF 2022 should be working now. Please let me know if you find anything else that's broken. I'll work on fixing those as well. So web encrypt is one where you are going to have to use some of these ideas in order to break out. You're going to be doing server-side template injection. So there's, if you know of Jinga, it's basically a templating syntax, and you will have the ability to put Python code in there, but you're going to have to actually get the flag. So that's a fun one. LACTF, there was a challenge 1984, which was it was really difficult. Let me actually pull it up. Should I go? But the nice thing about it is that it's configurable. So the way it worked is it had audit hooks, which are hooks that run when you run certain Python functions like exec or eval or input or read a file or anything, right? And it would crash the program every time you used a single one of them. But you can just change that to give yourself, okay, here. If I go to LA CTF. I go to 1984. And then if I cat out, literally 1984, right? You can see that it checks that your input is not more than 67 characters, but you can just edit this and make it like 100 or 200, and then bring it down in order to gradually increase the difficulty. Because 67 characters is very low, it's quite difficult, and also this it has only 3 audit hook events, and it uses up 2 of those, or uses up all 3 in creating the actual Pyjail. So you really can't use eval or exec or input or importing like OS or system or anything at all. So it's really difficult. But if you want to make it a little bit easier, maybe increase the number of audit events that you give yourself and slowly bring it down. Increase the number of characters for your input and slowly bring it down. And I thought that was a pretty fun challenge. So you guys might want to try that on your own. Okay, but yeah, that's it for the meeting. If you help out someone else, you can fill out the mentor tracking form. Currently, only Darshan is on the website, and he's pretty lonely on the CTF mentor section. So you only need 3 times to mentor someone or to be on the website. So you guys should do that. This is the form for it if you do end up mentoring someone. I'm going to leave this up until the end of the meeting, but feel free to just practice on your own. Does anyone have any questions, by the way?